All right, I am back here with self-recording for section 3.1 in Math 055. So, what has been requested is for problems number, and of course I don't have it in front of me. There we go. Wrong notepad. I have problem number 14, 32, 34, and 36, and this is on page 155. So this first problem here is determine whether the ordered pair is a solution of the given system of equations. Remember to use alphabetical order of variables. So, easy enough. So our problem is going to be down here. I'm going to flip the phone over here. Is number 14. So I'm going to quickly write this over here as 5 and 2 in the parentheses. And my first equation is a plus b equals to 7, and the second equation is 2a minus 8 equals b. So in keeping with the variables here, a and b is what we're going to plug into 5 and 2, so a and b. So with our equation here for this first one is going to be pretty simple, so it's 5 plus 2, since number 5 is in accordance with variable number a and 2 with b, so 5 plus 2, pretty simple math, 7. Over here is going to be a little trickier, so we're going to have 2 times 5, since 5 is still part of our variable for a, minus 8 equals 2, since b is still 2. Move that over here and try to zoom in, so there we go. So same thing, we're just going to solve the equation now. So 2 times 5 is 10 minus 8. And of course that equals 2. So the answer to this problem is the ordered pair is a solution for what is given here. So boom, boom. All right, for our next problem is going to be number 32. And this is solve each system graphically. Be sure to check your solution. If the system has an infinite number of solutions, use set builder notation to write the solution set. If the system has no solution, state this. So, looking at our problems here, we've got 32, so 6x minus 2y equals 2. And then our second problem, our second equation is going to be 9x minus 3y equals 1. So as we can see here, obviously it is not in y equals mx plus b or f of x equals mx plus b. So I'm going to repurpose the equations to where they follow slope-intercept form. So first here, I'm going to flip my phone over so I can write and record at the same time here, since my workspace is very small. Okay, first we're going to subtract 6x from both sides of the equation, so that's going to give us a negative 2y equals negative 6x plus 2. Now we want to solve for y, so we're going to divide by negative 2 throughout the whole equation. So that's going to give us y equals 3x. It is positive 3 because negative divided by negative is a positive, minus 1, since negative 2 divided by 2 is negative 1. So this is our slope-intercept form for that part of the equation. Now we're going to move over to this side. So same principle, we're going to minus 9x on both sides of the equation. So that's going to give us a negative 3y equals to negative 9x plus 1. So same thing, we are going to solve for y, or put it back into slope-intercept form. So we're going to divide by negative 3 on all sides. That gives us y, since it's positive, since negative, negative, and plus we don't want a negative for our y, equals positive 3x, same thing, because negative and a negative is a positive, and minus 3. What am I doing? Wrong. Back up. This is where fractions sometimes confuse me. So I take that back now. We cannot divide 1 by 3, so it's negative 1/3 as a fraction form. So that is our problem. So let me move over to our graph paper. Let me get it set up here real quick. Okay, so now since I've got my graph paper set up over here, looking at this equation, slope is going to be the same on both sides, so that's a giveaway. Our y-intercept is going to be -1 and -1/3. So going over here to our graph paper, I'll just move it here, make life easy. 1/3, so -1, and then 1/3 is going to kind of be there. So since our slope is 3, so we'll put that 3 over 1, so we know our rise and run. So we'll start off with my top part here of 1/3, so up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, even though I'm kind of running out of paper. Then we'll go 2, 3 over 1. That should be good for that side. So -1, same thing. We're going to go up 3. Hopefully I'm got 1, 2, 3 over 1. 1, 2, 3 over 1. And then 2, 3 over 1. So these lines are completely parallel. They are never going to intersect. That's a horrible line, but we're just going to go with it there. So this system for number 32 has no solution. There is no intercepts of either line, so not much we can do with that one. So now we're going to move on to number 34. So 34, our first part of the problem is y equals x plus 2. The second part of the problem is going to be 3y minus 2x equals 4. So same thing, I'm going to put both of these equations into y-intercept form. And so with this first, for y equals x plus 2, it is actually in slope-intercept form already, so I don't need to do much with it. However, I need to remember slope is 1 because x and 1, or any variable that's just by itself, is considered 1 in algebra, even though sometimes I don't quite understand that, but I just go with the flow. Our y-intercept is 2. So going over to the second part of the equation, now I need to move it over into y-intercept form, so I'm going to plus 2x on both sides of the equation. That gives me 3y equals positive 2x plus 4. Now I'm going to divide by 3 to get y by itself. That gives me y equals 2/3 x plus 4/3. So since that kind of, changes things up a little bit from the last equation, our slope is 2/3 and our y-intercept is 4/3. So let me get my graph set up here. All right, I am now back, so I'm going to start off with the first part of my equation here. So I need to put y-intercept as positive 2, so up 2. And of course, these are just going by 1. I should probably state that before putting random points down, but we'll just go with it. So since slope is 1, I'm just going to put that over 1 just so I don't confuse myself when I put my dots here. So up 1 over 1, up 1 over 1, and then reversed, down 1 to the left 1, down 1 to the left 1, down 1 to the left of 1, and I need to do a couple more, down 1 to the left of 1, because eventually these two parts actually meet. So that's for my first equation there. Second part, since my y-intercept is 4/3, I had to do a little research on this since it kind of threw me off, but basically it's 1 whole 1 plus 1/3. So it's going to kind of go barely above this line right there, and I will kind of zoom in. Hopefully you can see that. So then my slope is 2/3, so I'm going to go up 1, 2, 1, 2, 3. Let's see, 1, 2, 1, 2, 3, and then down. Okay, so I had to make sure I did that right. So going down 1, 2, and then 1, 2, 3, still reminding ourselves it's barely about the line there. So technically they do kind of cross points right there at that part. So our answer to this problem is going to be x is negative 1, 2, 3 minus 1 for y. So negative 3, negative 1. And just for kicks and giggles, I will go ahead and kind of casually draw a line, even though it is not the prettiest. And then, oh, darn it. Alright, works. Alright, for this last problem, for number 36, I'm going to go ahead and write out the equations as I've done before. So 2x minus 3y equals 6, followed by 3y minus 2x equals negative 6. So same thing, I am just going to put this back into slope-intercept form if it's not already. This second equation is not, either I was going to say it is, but it's not. So before I jump ahead here, I'll just subtract 2x from both sides of the equation. It's going to give me negative 3y equals negative 2x plus 6. Same thing, divided by negative 3 to get rid of the y, or make y by itself. That gives us y equals positive 2/3 x. Reason why it's positive is negative divided by negative is still the positive, minus 2, since negative 3 divided by 6 is negative 2, since it's a negative divided by a positive. Now this is my slope-intercept form. Slope is 2/3, and y-intercept is negative 2. Now moving on over here, same thing, I'm going to just move x over here, so I'm going to add 2x to those two spots. That's 3y equals positive 2x minus 6. Same thing, we're going to divide by 3, and I can tell you right now by looking at this equation, we're going to have the same thing. So then y equals 2/3 x minus 2. And I was right. 2/3 is slope and y-intercept is negative 2. So we have the same exact points. So with this particular problem, the line is infinite. There's infinite solutions. It is going to be on the same line, starting at negative 2 for our y-intercept and then going up. So I will casually just draw this on the graph. Negative 2. Same thing with this final graph. It is in increments of 1, 2/3. So 1, 2, 1, 2, 3. 1, 2, 3. Do the stair-step model. 1, 2, 1, 2. So that is for both lines. It's just going to continue on and on and on and on. And that line wasn't exactly drawn right, but we'll go with that. So that is the recording for this. Hopefully you were able to see it, and I will see you next time.